Whenever you want to draw the tangent, bring the ruler from the concave side of the curve and drag it towards the point and leave equal space on both sides. Then you will able to draw a very accurate tangent. Clear, boys? So this will be a very accurate tangent I'm going to draw. Look at that. Now this is touching the curve at point P. Note down this point. You want to see what is the x coordinate of point P. The x coordinate of point P is 2, and the y coordinate of point P, it is 1. So the first point is 2, 1. Second, I can use this point since it is on the x-axis, on the y-axis, so x coordinate is 0, and the y coordinate is 2.1. Now I'm ready to find the gradient of the tangent. The formula for the gradient is y2 minus y1 over x2 minus x1. So 1 minus 2.1 over 2 minus 0. When we do this, we can easily find the gradient. 1 minus 2.1 over 2 minus 0. That gives you minus 0.55. That's all with the gradient of the tangent on the curve. Let's come to the question number 2. It looks like a parabola, and the parabola is touching the origin. It is passing through the origin. He mentions that its equation is like this. So, boys, you remember we told you that a parabola, which is like this, his equation is y is equal to x squared. If the parabola is facing downward, its equation is y is equals to minus x squared. Clear? So in such situations, boys, an examiner may ask you to find the equation of a curve, maybe parabola, maybe some other equation of a curve, but the basic concept about the sketching must be known to you. Then you can easily find the answer for this type of questions. For sure, it's a parabola, so the power of x should be 2. So n is easy, n is 2. Whenever the parabola is facing downward, it means the coefficient of x power 2 should be negative. So a is a negative number. And he mentions a is an integer. So I may call it as -1, -2, -3, -4, so on and so forth. Now he mentions here, find the possible value. If the examiner writes possible word, it means there may be more than one answers. So I can write here -1, just, or -2, -3, -4, whatever you like. Also, examiner mentions here, find a possible value of n. So you may ask me, Mr. Omar, do we have some more possible values? Yes, we may have more possible values because y is equals to x power 4, y is equals to x power 6, y is equal to x power 8. These even powers of x are also making the same type of a curve, but they have like a different nature when they get closer to the x-axis. This is beyond to the scope of IGCSE. I'm not going to go to that. I'll just mention that you are well familiar with quadratic functions, so it's better to keep the possible value of n is just 2 squared. Am I right? That's all. The next question, he's again giving you the equation of a curve, and the curve equation is also provided to you, and the curve is drawn. It is drawn from 0 to 8. Check it out. From the x-axis, he is using only 0 to 8 for drawing this curve. He said, can you solve this equation? In graphs of function, if we solve the equation, we need to first look at the left-hand side of the equation. It should be the same as the original equation of the curve for which you have drawn the curve. So I can say that if this is x over 2, I got x over 2. If it is 2 over x, it is 2 over x. So the left-hand side is the same. Now on the right-hand side, this is just 3. 3 means I have to draw y is equals to 3 line on the same grid. So here is the ruler. I'm going to take my ruler towards 3. So I draw y is equals to 3 line. Although I don't need to extend the line behind 0 because the range, the values of x which are consumed by him is from 0 to 8. So I'm going to use this one. So y is equals to 8. You may extend it. That's not a big deal. I'm concerned about the point of intersection of the curves. So this is the first point of intersection. And this one is the second point of intersection. So it looks like 0.7. And this looks like 5.4. So 0.7 and 5.4. Next thing is I want to find the gradient of the curve by drawing a suitable tangent at x is equals to 1. I need to reach to the point where x is equals to 1. You remember this is x is equals to 1. Go up. This point is having the x coordinate 1. Can I check what is my y coordinate respective to that? So 1 and 2.5. So this point is 1, comma 2.5. I need to draw a tangent. So bring your ruler towards this point. So this would be the tangent. So it is passing through 0, 4 and 1, comma 2.5. I can easily write the gradient y2 minus y1 over x2 minus x1. So 2.5 minus 4 over 1 minus 0. Now I'm going to use my calculator. 2.5 minus 4 over 1 minus 0. So that gives you minus 1.5. This whole explanation should be done over here. And then you get your final answer, minus 1. Next question. We have a cubical equation. A cubical equation, when you draw it, it looks like this. Now, he has chosen some values of x. With regards to some values of x, values of y has been already found by the examiner. He left 2 spaces for you, and you need to fill it up. How? You just take out your calculator. On the screen, you need to type 3x squared minus 2x minus 1. Okay. Then press calc. Now calculator asks you for which value of x you want to find the value of y. I want for minus 0.5. I get my answer, 0.75. So I'm going to mention here 0.75. Is there any other value? Yep, 0.5. So press 0.5. Again, you got minus 1.25. Now I have A, B, C, D, E, and F points, and I want to plot all of these points on the grid. So minus 1, 4. This is the point. Then minus 0.5 and 0.75. Approximately, this will be the point. 0 minus 1, this is the point. 0.5 minus 1.25. Here you go. 1, 0, this one. And then 1.5, 2.75. At 1, 0, 0.5 is giving you negative 1.25. This is wrong. Negative 1.25. Yep, this is the point. Last, 1.5 is 2.75. 2.70. Clear? So now I'm ready to draw my curve. I need to check all of my values. 0 is giving minus 1. Minus 0.5 is 0.75. Minus 1 is giving you 4. And 0.5 is giving me minus 1.25. And 1 is giving you 0. And 1.5, 2.75. Let's draw the graph smoothly. It's a quadratic equation. It's not a cubical equation. I don't know why I said it's a cubical. It's square. It's a quadratic. That's why a parabola is formed. Now he says, draw a suitable line to solve this equation. So check on the left-hand side, what do you have? And match it with the original equation. So I have 3x squared, 3x squared. Oh no, this is minus 4x and I want minus 2x. This is minus 2 and I want minus 1. So it means both of the terms should go to the right-hand side. So what I'm gonna do, guys, I will send minus 4x on the other side. There it will become plus 4x, and minus 2 will go to the other side and it becomes plus 2. Got it? Now what do you need on the left-hand side? On the left-hand side, you need minus 2x and minus 1. But in mathematics, if you write something on in the equation of, on one side, you have to copy the same thing on the other side to balance the equation. Now, this is the same equation which you have already, for which the graph has been already drawn. Now, this is your right-hand side. Can you simplify it? So 4x minus 2x is 2x, and 2 minus 1 is 1. Wow. So I have to draw a new line. Y is equals to 2x plus 1. And for him, he said that I have to, after drawing the line, we need to check that where it cuts the curve, and then, we need to see the point of intersection. So y-intercept is 2 and this is 1. So I'm going to stand at 1. I'm trying to sketch this line. So the y-intercept is 1. I'm going to go 2 units up and 1 unit right. 2 units up and 1 unit right. So I'm ready to draw the line. Very good. So as you can see, our line is drawing our line is cutting the curve at only one point. And what this point is, it looks like 0.4. The point of intersection is 0.4. And there is only one space left. It tells you that the graph or the curve will cut the line at only one point, and that tells you that this point of intersection happens at x is equals to 0.4. Now we go to the cubical equation. When we draw the cubical equation, that graph is normally like this. The previous one was a quadratic. That's why we got a parabola. And the coefficient of x cube is positive. That's why it is like this. If the coefficient of x cube is negative, the graph will be like this. Let's try to complete our table. We need to write our equation into the calculator. Minus 3x plus 1, calc. Substitute minus 1.5. It gives you 2.125. 2.125. Now, may I change my value from minus 1.5 to minus 0.5 and see what the answer comes? 2.375. 2.375. Now, as you can see, all the y values are completed against x. We are ready to plot these points. How much are they? A, B, C, D, E, F, G, H, I, J, K. Minus 2.5. Minus 2.5. Minus 7.125. Somewhere here. Minus 2, minus 1. Minus 1.5, 2.125. Minus 0.5, 2.375. Zero 1, 0.5 minus 0.375. 1 minus 1, 1.5 minus 0.125. 2, 3, 2.5, 9.15. Let's try to connect them. Okay, so the graph which we have drawn looks like this, which is a cubical function. What's the first question? He said, draw a suitable tangent and find the gradient of a curve at x is equals to 2. Where is x is equals to 2? Why? This is x is equal to 2. Go up to the curve. I think I need to erase this one and draw it again because it's not very accurate draw. Now I think it's better to draw x is equals to 2. At x is equals to 2, what was the point? At 2 was 3. And this point approximately looks to me 1.7 or 1.60. I can easily find a gradient. Y2 minus y1, and is 0 minus 3 over 1.6 minus 2. 0 minus 3 over 1.6 minus 2. That gives you 7.5. So my gradient is 7.5. Next, we want to solve the equation graphically. So check that what type of equation you have, expression of x you have on the left-hand side. Is it matching? Yep. X squared minus 3x plus 1. It is the same as the equation of a curve. What do we have on the right-hand side? 1. Yani y is equals to 1. So we have to draw y is equals to 1 line, a horizontal line. How many times your y is equal to 1 line cuts the curve? It cuts the curve 3 times, so it means that I'm going to get 3 solutions. This is your y is equals to 1 line. Let's try to get 3 solutions. First of all, this will be your first solution. This is your second solution. And this is your third solution. So first solution is minus 1.1, 2, 3, 4, 5. Minus 1.5 is my first solution. Then 0 is my second solution. And then it looks like 1.8 is my third solution. Minus 1.5, 0, and 1.8. So these are the 3 solutions of this equation. Now, question number 6. We have x in the denominator. It tells you the graph is not smooth. It has 2 parts. That's why the examiner has drawn a barrier between the 2 set of values of x. So this graph, which is shaded yellow, these values will be joined together. And these set of values of x will be joined together and make 2 parts of the graph. Let's try to complete our spaces for y or f of x. You can call it f of x or y, same thing. So I'm going to write 1 over x squared minus 2x, press calc. And then I'm pressing -1. It is 3. Sorry, it is 3. Now 0.5, press again equal and write 0.5. So it calculates for you and it gives you 3. Now may I try to find for x is equals to 1? It gives you -1. Now I have how many points? A, B, C, D, E, and F. Then again, A, B, C, D, E. You can call them some other points, but I'm just trying to emphasize on the difference of the 2 curves. So this is F, G, H, I, J, and K. -3, 6.1. -2.5, 5.2. -2, 4.3. -1.5, 3.4. minus 1, 3, minus 0.55, okay. After that, 0.4, 5.5, 0.53, 1 minus 1, 1.5 minus 2.6, 2 minus 3.8. Let us join them together. Minus 3, we have 6.1, minus 2.5, it should be, yes. So it's like this. The first equation, which is to solve f of x is equal to 2. So we need to draw y is equal to 2 line. So y is equal to 2 line, you can see when you draw, it cuts the curve at only one point. Therefore, we will get only one solution. So approximately our solution will be 0.6. Now, on the left-hand side, we have f of x, on the right-hand side, 2x plus 3. So y is equals to 2x plus 3. What is the y-intercept you have? 3. The y-intercept is 3. And the gradient is 2 or 1. So go 2 unit up and 1 unit to the right. So basically, it gives us 2 points. Let's draw a line passing through these 2 points. So this is y is equals to 2x plus 1, 2x plus 3 line. Check that where it cuts the curve. It cuts the curve at this point. For me, it looks like 0.4. Now, as per the examiner, we need to draw the tangent at x is equals to minus 1.5. Where is minus 1.5? This is minus 1 point. And you look, this is minus 1.5. So I'm going to go to the point. I draw a tangent here. This is a tangent line. It cuts at this point, or it cuts at this point. I can call it as 0, 1. And this point was minus 1.5 and 3.4. I'm ready to find my gradient. The gradient is y2 minus y1. Yani 1 minus 3.4 over 0 minus minus 1.5. So m is equals to 1 minus 3.4 over 0 minus minus 1.5. It gives you minus 1.6. That is the gradient. So use the tangent. Yeah, answer will be written here, minus 1.6. Thank you, boys. So I have done with all graphs of function questions given in the review pack. Inshallah, in the next video, I will explain